Now in this session, I look at an example problem on scale-up of mixing and agitation equipment. So here is the problem. A pilot plant vessel 0.3 meter in diameter is agitated by 6-blade turbine impeller 0.1 meter in diameter. So dt is 0.3 meter and dA is 0.1 meter. When the impeller Reynolds number is 10 to the power 4, the blending time of two miscible liquid is found to be 15 seconds. So the impeller was running the Reynolds number 10 to the power 4, and for this case the mixing time was obtained as 15 seconds. The power record for this case was 0.4 kilowatt per meter cube, meaning that's given P over V for this case. Now there are two problems. What power input will be required to give the same blending time in a vessel 1.8 meter in diameter? So we have dt2, this is 1.8 meter. Then what would be the blending time in the 1.8 meter vessel if the power input per unit volume were the same? So part B says if P2 over V2 equals P1 over V1, what would be the blending time? So part A, you need to calculate the power input, and part B, you need to calculate the blending time if the power per unit volume remains the same. Now for this case, we are given Reynolds number to be 10 to the power 4. So consider turbulent flow, and we will use the equation P equals KT N cube dA power 5 rho. Now we're also given P1 over V1 to be 0.4 kilowatt per meter cube. Now for part A, we have blending time remains same. So this tells us N2 will become N1. Now we know that V proportional to dA cube. So if we plug in there, we'll get P over V to be some constant times N cube dA square rho. So from there we'll get P2 over V2 or P1 over V1 will be simply N2 over N1 cube dA2 over dA1 squared. Now here, as I said, for this case N2 becomes N1, so this becomes 1. So we'll have P2 over V2 over P1 minus V1 will become dA2 over dA1 squared. Now we're not given the dA2 information, however we are given the information in terms of dt1 and dt2. We know that dA2 over dA1, that will simply dt2 over dt1. We always maintain the ratios, which is given as 1.8 meter over 0.3 meter equals 6. So this will give us P2 over V2, P1 over V1 to be 36. And from the given value of P1 over V1 to be 0.4 kilowatt per meter cube, we'll get P2 over V2 to be 36 times 0.4, that becomes 14.4 kilowatt per meter cube. Now part B says if the power required per unit volume to remain the same, what will be the mixing time? Now we know that for this case we don't have this anymore, N2 equals not N1, because now power required per unit volume remains the same. So N2 will be different from N1, and that's why the time for mixing will also be different. Now again, from this formulation we get, if we put P2 over V1, this should be V2. These ratios to be 1, we get N2 over N1 to be dA1 over dA2 power 2 over 3. Now we don't need to calculate really N2, we need to calculate TT2. So also we know that N2 TT2 will be N1 TT1. Here TT2, that's the mixing time. So we have TT2 over TT1, that's N1 over N2. So this will be simply inverse of this. So dA2 over dA1 power 2/3. So you know that dA2 over dA1, that given as 6. So we'll have TT2 over TT1, 6 power 2/3, which becomes 3.3. So TT2 will be 3.3 times, and TT1 is given for this case, and TT1 is given for 15 seconds. So TT2 will be 49.5 seconds. So we have for the first case, the power requirement is 14.4 kilowatt. For the second case, the time required for mixing is 49.5 seconds.